Hi everyone, in this video we're going to go over Leetcode, find minimum in rotated sorted array problem. Major tech companies like Amazon, Microsoft, LinkedIn, etc. are asking this question while they're conducting their technical interviews. I hope you will find this video useful for your technical interview preparations. Let's start with reading the question. Suppose an array sorted in ascending order is rotated at some pivot unknown to you beforehand. So we have an array, it's in ascending order, and it is rotated at some pivot unknown beforehand. So at this point, this array is rotated, so 0 becomes here, 1 next to it, and 2. So it's increasing, there's sudden decrease, there's a pivot point, and increasing again. So this is our pivot point here. Increasing, sudden decrease, and increasing again. Find the minimum element. You may assume no duplicates exist in this array. We have examples here. In this case, our minimum element is 1, because it's increasing, then this is the minimum element. We need to return this 1. And in this case, the minimum element is 0. So we need to return 0. This is a typical binary search problem. If you don't know much about binary search, it would be a good idea if you learn binary search on YouTube, on Geeks for Geeks, or Wikipedia and come back to this video after. That would make things easier for you. So let's see this on Whiteboard and see how it works. So in a binary search, we have high and low ends, and we find the midpoint and do the search in logarithmic time instead of O(n) time. So in this case, this is slightly twisted version of the binary search. Again, we find low and high values. We set low 0 in the beginning, and high nums linked -1 here. When high is greater than low, in this case, we find the midpoint, which is low plus high minus low divided by 2. So high minus low divided by 2 is midpoint, which is, in this case, 8. This is the twisted part. We need to check if this mid number is greater than the high number, because in a sorted array the numbers should be increasing. It shouldn't be less than the mid value. Number 3 the high value shouldn't be less than the mid value. There's something wrong here. We are looking for that. So if midpoint is greater than the high, then we move our low point to mid +1. This means we are searching this part of the array. We are basically looking for the pivot point, and from the pivot point we are dividing the array into 2 and finding which part we are searching for. So in this case, midpoint is greater than high, so we put the low here. This is our new low. Low plus high here. So we'll keep searching in this part of the array, and we will keep searching low plus high minus low divided by 2, which is this is our new mid. Low high divided by 2 is our new mid here. And again we check if nums of mid is 1 is greater than nums of high 3. No, it's not greater. Otherwise, now this is our new high value, Then we shift high to this here. So basically we shift our high and bring it here. And this is our low. Again, we do the binary search here. Check low plus high plus minus low divided by 2. That will become 0. And this is where it breaks. Because then we make high equals to mid. This is our new mid. New mid will be 0 and high is equal to mid. So this while loop breaks. And our low is 0 and we return 0. Num's low. And this is how we find the minimum. To make it clear, I'll explain again. So first we find the midpoint. Then we find which part we want to search for by comparing these two values, mid and high value. Mid is greater than high, then we are looking for right hand side because there is this side is less than the other one. So our new low becomes mid plus 1 here, and now we are doing the search between low and high. In this case, we do low plus high minus low divided by 2. Our new high becomes this. And we do one more high and low. Then finally, we will find this loop breaks and we will return low. So this is our answer. I hope this makes sense. Here's another example. Again, we have low, high, boundaries, and midpoint. We do the low plus high, low, high minus low divided by 2 to find midpoint. Then check if mid is greater than high. In this case, it's less than high. So what we do is this time, so this doesn't work because mid is less than high. Then that means we are searching this part of the array. Our minimum should be in this side because this part is going in ascending order. There's nothing wrong here. So what we will do is we'll move this high here, and now I'll get rid of this mid because we'll find a new mid here. Oh. So low plus high divided by 2. In this case, our new mid becomes here. And we again check low and high. This time, mid is greater than high. If you see this part, then this means our low becomes mid plus 1. We get rid of mid again, and our low becomes mid plus 1, sorry. Again, we do another binary search here, low plus high divided by 2, and that becomes mid becomes 0. Then we break this loop because our high and low is equal now. We break this loop and return low. So if this doesn't make sense to you, I guess it's a good idea if you look binary search again and try to understand this question, because it's a binary search, but it's a shifted binary search. I mean, we do two binary searches here. First, we find the midpoint, then we decide which part we are looking for the minimum number. If this is less than this is weird. I mean, it shouldn't be less than midpoint. It should be in increasing order. So we are searching for this side. Again, we narrow down our search in logarithmic time. then this is high, then between this and that, then our low, then we will return this one. And in this case, we are looking for this, and this we find the mid here. It's in ascending order. Nothing is wrong in this side, so something is wrong in this side. Then we do another binary search. Then we find new mid, and this is the new mid. And we do low and high again. Sorry, mid is this time greater than the high. So this time is normal. This part is normal, but it should be somewhere in this side. So we move and we finally find 0 this way. So this is pretty much how it works in logarithmic time. It's 2 log n, but constants are removed, so it's log n time. So it should be it. So this is the same code again. Low is 0, linked -1. High, low, we find the mid. This is where we solve this question. Check if mid is greater than high, then low is mid +1, searching the right hand side. Otherwise, searching the left hand side by putting high to the mid, then return nums low, the minimum number. Let's submit and see. All right, so this works. I hope you find this video useful. There are other problems I will be solving in this video series. So if you subscribe to my channel, I hope to see you in the future videos. Thanks for watching.